Welcome to this TRANSYT video. This video shows some of the tools built into TRANSYT to help with the setting up of phases, stages and stage sequences. I am using TRANSYT 16 during this demonstration, but this video applies equally well to the forthcoming TRANSYT 17. The file I'm showing you at the moment is modelling a 3-arm fully signalled junction with one lane on 2 approaches and 2 lanes on the third. There's fully protected right turn movement on that arm. You're welcome to follow along with me as I set up a suitable signalling arrangement for this scenario. The controller stream data screen is accessed from the left-hand vertical toolbar and presents all the timing information relating to phases and stages. This is the main location where you would generally enter or update all your controller data. The screen contains a list of controllers in the file to allow easy selection of each one, whether more than one, and it also contains a set of tabs that are designed to direct you in order of how to set up phases and stages. This is achieved by simply working from left to right through each tab, starting with the second tab. Paying attention to the presence of any buttons within each tab that acts as reminders of any additional data that should be set up as you enter the required data within that tab. There are a number of ways to define phases and stages in the controller, and we're going to explore a couple of these, starting with a semi-manual method. To do this, we need to define which phases we need. The first tab shows all the phases that the controller has, and in this case we have just the one in this existing file, the minimum allowed within the TRANSYT file. Looking back at the diagram on the right hand side, we can see that we have 3 approaches and one has 2 traffic streams, each with 1 lane each. To offer the model the full flexibility to work out the best sequence of signals, we will therefore need 4 phases. So to start with, we go back to the controller streams screen and click Create New Phases and add in 4, replacing the existing ones. So having set up 4 phases here, all we need to do is go back to the diagram and define which phases are controlling which traffic streams. This can be done via the data editor by editing the traffic stream signal data. By simply typing in the phase here, but generally it'll be easier to do it from within the diagram, so that's what I'll use here. So going back to diagram, the first thing I would like to do is make sure that I'm showing the phases all the time. It makes it easier to set them up and confirm that you've got them set up correctly. So starting with this one I'll leave as phase A, controlling this traffic stream. Right click on here and then select phase B for that one. Select phase C for that one, and for the right turn maneuver I'll select phase D on here. So having done that, I'll go back to the controller stream, and you may notice on here that we'll leave most of the data here the same, but the traffic type on here is set to unknown. So we'll just set that to traffic for each of these. This has no impact on the traffic model in this particular scenario, but it does feed into some of the graphics in some of the other screens later on. You'll also notice on this screen in the bottom right corner there's an intergreen matrix. This is an example where these tabs on this particular screen are hinting at what you should be doing next. So open up the intergreen matrix on here. At the moment the intergreen matrix is completely blank, but as you gaze over to the diagram again, you may notice there's a scale rule on here, and this is indicating that I've actually scaled this diagram. So in fact I can actually automatically calculate all the conflicts of this junction and the associated intergreens using a very useful feature within the intergreen matrix. Going down to the very bottom corner here where it says geometry, I can select that. Out of these 4 buttons, I won't go through all of them, but this one in the top left, clear all, then find conflicts of values. If you're starting from scratch, this is what you'll be using. It will generate all the conflicts for you and the values of integreens. Click on that, and there you see it's populated this integreen matrix. And you can also see from this that it's also correctly identified that phase A and C can run together, which it can, and also phase C and D can run together as well. So we've now set up the integreens on here. So I can close this screen. We can now move to the Stage Library tab in order to define our stages. You always have the option of creating and defining stages manually, but on this occasion I'm going to use the Auto Generate Stages button. You can see how the program has automatically grouped what phases can run together within the relevant stages. We'll skip the Phase Delays tab and come back to that later on. We can now generate automatically all the possible stage sequences. The program will automatically produce the 10 shortest sequences, but in this case there won't be that many. In fact, with 3 stages there is only a choice of stage 1, 2, then 3, or 1, 3, then 2. Let's now have a look at how the phases and stages can be visualized within TRANSYT. Convenient options here to bring up the stage sequence diagram and the phase timing diagrams. They're available from the vertical toolbar as well, of course. So here is the stage sequence diagram, and here's the timings diagram. Yeah. The stage sequence diagram shows the stages diagrammatically. The blue highlight behind the stage numbers in the top left-hand corner of each stage indicates that this sequence is a currently used one. In this case, it's sequence number 2. Those sequences that are not current are shown in yellow with background colour. So if I went to select a different one on here, you'll see how sequence 1 has a yellow background. Similarly, on the timing diagram, you have this yellow background as well, and a blue one representing the current sequence. You also spot that on the data outline there's a little asterisk next to the one that is the current one. So there's several different places where you can get an indication of which sequence is the current one. Current being the one that will be used if you press the evaluation run or full run buttons to run the traffic model. Both of the timing and stage sequence diagrams can be used to edit the stages, phases, sequences and timings in various ways, but I will reserve demonstrating this for another presentation. Having previously entered some traffic flows into this file, we now have entered sufficient data to run the file. I will run the evaluation run first, just to see how the network performs before optimizing the signal timings. So the evaluation run button here on the main menu. And having run the file, you can see that the highest degree of saturation in this junction is 93%. It's shown in red because it's over the default 90% DOS threshold. And this is easily identified in the diagram as traffic stream A. You can see here the 93% saturation here shown on the traffic stream. So let's do a full optimization run and see what happens. And this has had the effect of improving traffic signal timings considerably, and the performance of the network has got a lot better. Highest degree of saturation has dropped down to a very acceptable 69% value. So let's now look at some of the animations of these improved timings. First, I'm going to hide the phase roundels. You can temporarily see these by clicking on the controller even when this option is switched off. So if I go into signals, I can switch that off, but if I want to see them temporarily, I can click on the controller like that. This is just so that it doesn't get in the way of some of the other items I want to show on the screen just now. Now I will demonstrate how to animate the signals through the length of the cycle. First I need to click on the Animate button on the top menu of the network diagram. This brings up an additional screen on here, which you can press the play button on and maybe increase the animation speed as well to make it a bit clearer what's going on. Just close this temporarily. And as you can see across the stage sequence diagram and the timing diagram, you can see in the case of the stage sequence diagram a blue highlight round the stage that's running, and in the timing diagram you get a vertical blue line indicating where within the cycle the animation has got to. Going back to the diagram briefly, another aspect of this, if you want to see something similar to the timing diagram on the diagram itself, you select the controller, right click on it and say show timing wheel. This brings up a timing wheel and you can see the animation is replicated on here, and if I zoom in I can show you some elements of how this works. You can move the timing wheel around relative to the controller position, and if you move the controller, both move together. So in that way you can position these exactly where you want them within the diagram, particularly so it doesn't get in the way of other artifacts on the screen. Other controls relevant to this particular timing wheel is that there's a green dot at the top that allows you to enlarge or reduce the size of the timing wheel. And you may notice that it shows you the stages, stage starts and ends on here, and also shows you the, in brackets, the length of each stage. If I just pause or stop the animation briefly just now, I can also show that you can actually change some data on here. So click on either the start or end of a stage and you can move the stage around, and you can do a similar thing within the timing diagram as well, but I'm just demonstrating it using the timing wheel. You notice also when you pick it up, it also tells you how far you've moved it in one direction. So if you do want to move it forward by say 10 seconds, then you know exactly when to let go of the mouse to position it there. One other thing is, if you want to change the offset's not relevant in this particular file because there's only one controller, but in networks we have multiple controllers, it will become relevant. And at the moment the offset, which is the start of stage 1, is currently 91 seconds. You can rotate that round as well, so all the stages rotate round with you, so all the split times are being retained, but the offset is being changed instead. And I'll put it back to where it was. Also, while you're animating, you can also show the red and green periods in a number of ways on the diagram. The signal stages can be shown via the phase rounders, as you've already seen, of course, or on the traffic stream connectors, or on the lanes within each traffic stream. Which one you use is likely to be affected by either the personal preference and the combination of that and the circumstances. You don't want to have too many artifacts on the screen trying to compete with each other, so this is why certain ones will work in certain circumstances and others won't. So let's show you a few of these. Start the animation again, speed it up a bit, and now on here under the signals drop down, you can see that you can add them onto the phases as we saw before. You can add them onto the connectors, so the connectors will turn red and green now on here instead. I'll switch that one off and then choose another one. You can show them in the stop lines, and that's why I decided to hide the phase rounders, because they sit on top of these and it will obscure that red-green colouring. And the other option is show it in the links and traffic streams. This is the most bold way of displaying the red and green times and can be really effective when you're zoomed out to a larger network, because it's a lot easier to see. And I'll speed that up a bit. You'll see how they're changing as you rotate around the cycle. I'll pause that. And finally, I'll just switch some of these off. The other thing you can do, normally leaving them on the stop lines is quite a useful idea, is you can present some data on here. So I'll choose traffic on here, which shows a combination of queues and occupancy, and then again start the animation to show that on here. In the presentation, I'm not going into the details of explaining all the different effects, but I'll just demonstrate this one very briefly because it's one of the more useful animations in the diagram. Again, I'll stop that. So we will now return to the controller stream data. I will now show you how you can define your controller stages, stage sequences and phase delays using one single button. Firstly, to demonstrate the power of this capability within TRANSYT, I will need to change one of the intergreens. So let's just close that. Go into the intergreen matrix again. I'm going to change this one here from 5 to 10. You'll see why I've done this later on once I reset up the stages and phases. Also, to go back to start, I'll delete that sequence there. I'll go in here and leave the phases because I do need these. Just setting up the phases you do have to do as you did before, but I'll also delete the library stages off here so there's none left on here as well. So we're left with blank timing diagram and blank stage library on here as well. So I'll go back to this tab on here. Here's the button, Generate Optimum Sequence. I click that one button and instantly what the program has done for you is it's taken the phases that you've defined, is used that in combination with the diagram to work out the suitable stages. So based on the intergreen matrix that you have set up, it will create these 3 stages, library stages for you. It will have created the stage sequence for you as well. All of this to try to optimize the junction on the basis of minimizing delay. And also in here you may notice you've got a phase delay as well. And you can see that represented here of a phase delay. Go and move this along a bit. You can see going from phase C to B, there's this phase delay of 5 seconds. And this is the reason behind why I was changing the intergreen, just so that this effect would be showing up. So very powerful feature. Ideally used when you're first starting off a file, haven't put in any stages, haven't put any sequences in there, haven't put any phase delays. So it gives you a very quick pin through the paper solution so that you don't waste any time trying to set this up, and can be used very effectively for more complicated scenarios compared to the one I'm showing here, which is relatively straightforward. As we move towards the end of this presentation, I will now wish to demonstrate how you can investigate the impact of using different stage sequences. The Generate Optimal Sequences button provides only one sequence, so I will return to the Stage Sequences tab and use the Auto Generate Sequences button again. Obviously I could have just manually created a sequence myself by adding in a new one and specifying that, but the button's easier to use. So now we've got both sequences back, I can then use the Run All Sequences button on here. So I'll do that. Obviously I want to optimize the timings for both sequences to get the best results, so I'll do that. And a little pop-up table will appear indicating the performance of the 2 sequences, giving you some of the most basic summary information. You may notice that sequence 1 is very marginally worse than sequence 2 on here. But you will notice that the program, when it pressed the Auto Generate Sequences button, did actually choose the second sequence, which is the better of the 2, and that's not entirely by chance. The process that's carried out picks the sequence with the lowest possible minimum cycle length by default, and that in effect selects the sequence with the least amount of total lost time across the 3 interstages. And this makes it more likely than not to be the best solution in the simple scenario I'm using here, and in this case it was. That is not always going to be the case, but in this particular one it was. Finally, if you wish to examine the timings in tabular form, the resultant tab on the right of the controller stream screen gives you quick access to either stage change times or the green periods, as shown on here. Stages and green periods. I hope what I've demonstrated will give you confidence next time you need to set up controller stream data in TRANSYT. I'm Jim Binning, and that concludes my presentation. Thank you for watching.